it on that beat, ho.
This is the example video for improper integrals. Our first example is the integral from -1 to -infinity of 1 over 1 plus x squared dx. And the reason this is an improper integral is our lower limit is -infinity. So the way we do this is we first rewrite this as a limit as a approaches -infinity of the integral from -1 to a of 1 over 1 plus x squared dx. So that's step 1. Next step is to evaluate the integral. So integral of 1 over 1 plus x squared is inverse tangent of x, and this is evaluated from -1 to a. If we evaluate this integral, it's inverse tangent of -1 minus the inverse tangent of a. And the inverse tangent of -1 is the angle where tangent is -1. If you look at the unit circle, inverse tangent function's domain is from theta equals pi over 2 to negative pi over 2. And here tangent is -1 at negative pi over 4. We have negative pi over 4 minus inverse tangent of a. And since negative pi over 4 doesn't depend on a, we can pull it out of the limit. And we can pull this minus sign out of the limit. So now we have the limit as a approaches -infinity of the inverse tangent of a. And if you look at the graph for inverse tangent, we have two horizontal asymptotes at pi over negative pi over 2 and pi over 2. And since we're approaching -infinity, this value is going to be negative pi over 2. So we have negative pi over 4 minus negative pi over 2. That is just positive pi over 4. So our second example is the integral from positive infinity to 1 of 1 over x to the 1/3 dx. So this is an improper integral because our upper bound is positive infinity. So our first step is to turn this into a limit. The limit as a approaches infinity of the integral from a to 1 of 1 over x to the 1/3. And we can rewrite this as x to the negative 1/3. So now we evaluate the integral. Integral of x to the negative 1/3, we add 1 to the exponent. So we get x to the 2/3, and then we divide by that exponent. So we get 3/2. This is evaluated from a to 1. And this is going to be a to the 2/3 minus 1 to the 2/3. And since this is the only thing that depends on a, we can make this limit as a approaches infinity of a to the 2/3 minus 1, because 1 to the 2/3 is 1. And if we let a to the 2/3 if we let a go to infinity, this also approaches infinity. So this whole thing diverges and has no value. So our third example is the integral from 4 to 0 of 1 over x to the 1/4 dx. And the reason this is an improper integral is because if we look at the integrand as our f of x, we see that f of 0, one of the endpoints, approaches positive or negative infinity. So we need to rewrite this as the limit as, let's say, c approaches 0, and we're coming from the right side, because on this interval from 4 to 0, the right side of 0 is on the interval. So we limit as c approaches 0 from the right of the integral from 4 to c of 1 over x to the 1/4 dx, and we can rewrite this as x to the negative 1/4. Let me evaluate this integral. Add 1 to the exponent, you get x to the 3/4. We divide by the exponent, so we multiply by 4/3. Evaluate this from 4 to c. And we get the limit as c approaches 0 from the right of 4/3 times 4 to the 3/4 minus c to the 3/4. And since this part is the only part that depends on c, we can rewrite this as 4/3 times 4 to the 3/4 minus the limit as c approaches 0 from the right of c to the 3/4. And as c approaches 0, for c to the 3/4, we just get 0. So our final answer is 4 times 3 times 4 to the 3/4. Since 4 is just 4 to the first power, or the 3 over 3 power, we can add the exponents, and we get 4 to the 7/4 over 3.